Hello, this is Module 4, Investigation 8, the inverse of exponential functions. Up until this point, we have been unable to algebraically solve equation where the unknown is in the exponent. We utilize our graphing calculators in order to solve these equations. So in this investigation, we will learn how to solve this equation algebraically. So in number one, okay, we're gonna actually figure out the exponents without using the inverse. All right, so number one, without the calculator, isolate the following equation. So think about what value of the x makes each equation true. So in number one, so choose the x power is equal to 10. So I was thinking about, okay, so 2 to the first power, which is equal to 2. 2 squared, which equal to 4, 2 cubed, which equal to 8, and 2 fourths equal to the 16. So we are looking for the number as 10, which is 10 must be between the 2 cubed and 2 fourths, because 2 to the cube is 8 and 2 to the fourth is 16. So I want to say x is about, we just need to do the best guess, okay? So I want to say x is about 3 point something, right? Now, in number 2, 17 to the x power equal to 10. So 17, the first power is already 17, right? But I'm looking for equal to 10. So 17 to the 0 power is equal to the 1, right? So I know that x must be, which is a 10, must be between the 7 to the 0 power and then 17 to the first power. So I want to say it's about 0 point something, right? Which is x equal to, right? All right, B, describe the process, things you use to determine your solution in parts. So what I do was, I raised the power of factors and I try to match the value to the other side here. So what does each of the solution in part A represents? So the part 1 was the 1 unit growth factor increasing by 1 as an exponent, right? As of 2. And then number 2 is the same thing, but 1 unit growth factor of 17 this time. So for the equation in part A, what information was needed to determine the value of the exponents? We need the both of base value and the results of exponentiation need to be known. So determine the solution of the equation exercise 1 involve the undoing the process of exponentiation. Instead of the raising a base to exponents, we determine the exponents to which a number of the base is raised to obtain the sum number. So as seen in exercise 1, it can be difficult to determine the exact number of the times base value is a factor of the some other numbers. So standard way to expressing the specific value of the unknown exponents when they provide the base value and results of the exponentiation. Utilize what we call the logarithmic notations. So as an example, to represent the number of the time 5 is a factors of 125, we write as we write it as this one. So this is actually the meaning of, this is the meaning of this. So which is a number of the number of the times of 5, which is a factors of 125. In general, we say that the log, well, the base b of the m represents the number of the time b is the factor of the m. So using the logarithmic notation, represent the exact solution to the equation of the part A is x equal to the log, which will be using 2 for the 10, which means number of the times of 2 of the factor of the 10. And also the other one is x is log base 17 to the 10th. So describe what each of the following logarithmic expression represents, which is, this means this is let's say this is equal to the x. That means 16 to the x power 4. If I say this equal to x, 3.4 to the x power equal to 17.2 equal to the x, and 19 to the x power equal to 2.7. Okay, all right, so yeah, that's what it is. Okay, all right, let's go to the next page to talking about logarithmic function. So when x is a positive, I'm looking for this one. Okay, so x is a positive, b is a positive, and b is not equal to 1, when y is equal to log with the base b of x is equivalent to, so these are the same thing. So f of x equals to log b of x is a logarithmic function with a base of b. So number 4, without using your calculator, determine the estimated value of the value to make the equation true. Okay, so before we do this, I want to actually show it to you as rule that we just make it here. Okay, so which means when you have y equal to the log base b of x, which is same as, you can put that as b to the y power equal to the x. So there's some rules we need to remember. Okay, so when you have because when you have an exponential form, we can always convert to the logarithmic form. All right, so the vice versa. Okay, so or logarithmic form, we can convert to the exponential form too. But when you need to understand the logarithmic form, which is we are solving for any variable from a variable from exponent. That's what we call the logarithmic form. So let's say if you have let's say 2 to the 4 equal to 16, right? So in order to convert it, which is 4 is the log base 2 of 16. But another way is actually the 16 is 2 to the 4, right? So as you notice, this number and this number is always the same. But there's a condition though. You have to have a same number on this place. So if I make that as actually the form, if you have a log with any base to the x to the m power, it's always same as this one. Oh, sorry. We have to actually match the base, okay? So as long as you got b here, okay? All right, so this is what you need to remember. So as long as you match the base, then we know the x is a b, and then we can do this, okay? So let's go back here. So rewrite the following exponential equations in the logarithmic form, which means we are solving for the exponents, which means base for the x power is going to be the base of the log of the y. Same as here too, but this time we're only the base for the a power is 5, so you need to divide by 1.5 both sides. So b over 1.5 equal to the 5 to the a power. And then in order to solve for a, it could be log base of 5 of b over 1.5. So you can do the same thing as the other problem too, which is this time 4t is exponent, so log base of 2 for m. And this time, of course, you need to divide by 3, which is now you have a base the power 2k. And then in order to find the 2k is the log base of 5 of q over 3, okay? Now, without using any calculator, determine or estimate the value of the variable, okay? So in order to find this, actually, you can do this, okay? So I'm going to match the base 4 as a 2, which is a square of 4y, isn't it? So since we match the base of 2 and 2, now you have to say y is equal to 2. So this 2 I'm talking about, okay? Same here too. So log base of 9, but 81 is same as a 9 to the negative 2 power. And then t must be equal to negative 2. But c, actually, the base cannot be matched each other, so you have to say 3 to the k equal to negative 2, but that's not possible because 3 to the k is always positive number. So it's a no solution. And then this is actually the d is, there's no way we can match the 5 and 10. So in order to solve 5s equal to 10, and then you just need to, without using calculator, so now we have to guess the best, okay? So 5 to the first power is a 5, second is 20, so 10, which is in between the 5 to the first power, between the 5 to the second power, right? So it's about s equal to about 1 point something. All right, number 5. Logarithmic functions are inverse of the exponential functions. That is, both functions show the same relation between the two quantities. So, but the input and output quantities are switched. So, graph of function is a log. So this was to be the output for the exponential, and then this is actually the input for the exponential, but we switch around here. So plot the point, which is starting from the 1/2, which means you are formats, which is x and f of x. So first x is a half, which is you got the log base of half. Okay, so this one is about to match to the, if you can use a calculator, okay? So it's going to be the negative 1/2. So about here. And then when you have a 1, which is a log base of 1, it's always a 0. And then when it's a 4, log of base of 4, which is a 1. And then 16, which is the 4 square is a 2. So 16 is the 2 right here. Is it 16 right here? Okay, yeah. Yeah, so this is how you match those, okay? All right, so this one is actually the how the value is increasing as a function. Okay, so it's going to be I'm going to say the 4 unit growth factor. And then explain how you know that the y increases less and less, and for equal increase of x, yeah, the graph is graph is getting flatter. Okay. All right, now B, determine the average of the rate of the change of y with respect to the x. Okay, so increase from 2 to 4. So which means you have to use f of 4 subtract f of 2 over 4 minus 2. So f of 4 is going to be a 1. And the f of 2, which is, if you're using it, I got the 0.5. and then over 2. So it's going to be 0.25. Now x is increased from the 4 to 6, which is f of 6 subtract f of 4 over 6 minus 4. So f of 6, I got about 1.29, subtract 1 and over 2. And then I got about 0.145, okay? Alrighty, and then now on the C and D, which is now you can change the base of the 2, base of the 0.5 instead of the 4, okay? So you can do that too. And also the very important property that we should learn from the logarithm properties here. So the property number 1 means when you have a product becomes sum of the two log. When you have quotients, it's going to be a difference of the two logs. And then when you have exponents, always put it as factors with the logs, because a log is the meaning of the exponents anyway. But m and n must be the possible ways, okay? Alright, so let's look it up the number 9. So use the property the log to simplify the following expression. So when you have the ln is actually the base is e. So ln means the same as a log base of e. We call that ln, okay? So this means it's a sum, which means you can put that as x times x, which is ln x squared. So we use the product rule, which means the same as 2 ln x. The b base is a 3. Now you get 5 and 2, you can multiply, which is we have a base of 3 of the 10. And then it's a quotient, so what you need to do is just divide it. So log base 4 of 4, which is a 1. And then that's the product, so log base 3 and then 2 times 3, which is a 6. And then this is actually log base 3 of 9 and 4, you multiply. And then 6 you divide by, okay? So which means log of 3, 36 is a 6. It's a base of 7. And then 49 over, we can use a negative 3. So this is undefined, okay? We can't do this. Now, solve each of the following for x, okay? So number 10. So what you can do, basis of 5 to the cube power, which is the same as 30x squared. So 5 cubed is 125 over 30x squared. And then divide by 30. And then x squared equal to 125 over 30. And then in order to find the x is, okay, so square root both sides, but always a plus minus roots, okay? So x equal to plus minus. And then you can just reduce it. Actually, the 5 goes 6 and 5 goes 25, right? So you can say 25 over 6. Okay, when you have a log, but there's no base, which is a 10 to the 0 power equal to 1.5x. Okay, so divide by 1.5. But 0 power is a 1 over 1.5, which is equal to x. And then you can simplify as x equal to 2/3. All right, first of all, you use a product rule, which is multiply x to the 2x equal to 3. And then 3 cubes, same as a 2x squared. And then 27 over 2 is x squared. And the x is a plus minus square root of 29 over 2. And then you can just use a calculator to get the approximation, okay? All right, and then also, yeah, if they say log, which is same as log with a base of 10, okay? All right, now you have a base of 10, and then g of x is log of x. So they want to compare here, okay? So when x equal to -2, which is you're using the f function, which is f of x is a 10 to the x power. So it's going to be 0.01, 0.1, 1, and 10, and 100, right? But if you plug it into the log, so this is a log of x, okay, so this becomes -2 and -1. and 0 and 1 and 2. Okay, so now we have a table. So what happened here? Okay, sorry about that. And then we are using the composition to find this problem. Okay, so now f of negative 2. So function f of negative 2 input as here. And the output becomes 0 0.01. So this is equal to the g of 0 0.01. Now g function of 0 0.01 is right here, which is equal to negative 2. And then the second one, f of 0 equal to 1, so which is g of 1. G of 1 equal to the 0 if you use a table. And then g of 1. So g of 1 is going to be 0, so it becomes f of 0. Then when you look at the function as x equal to 0 equal to 1. And then, so as a rule, because these two functions, these two are inverse, okay? So which means whatever x you plug it in, come out as that. So it's going to be 10, it's going to be x, and it's going to be x, okay? So why? Do you notice about the relation? Because they are inverse functions. Okay, so when you use the inverse functions, and then whatever x you put it into the composition, the value always come out the same. All right, so that's all for the module 4 and investigation 8. Thank you for listening.